Okay, we're going to continue with rationals, but today instead of worrying about the graphs and what the functions look like, we're going to try to solve a rational equation. So that's basically any equation that has fractions involved, we're going to try to solve for x. So you can see in this case we've got looks like a cross-multiplying type question. We're multiplying by common denominators. We end up getting a simplified equation that we can factor, and we end up getting a couple of solutions. So what we're going to look at today is how to solve these things with graphing and with factoring. So first off, we'll look at graphing. Remember, just like any other equation we've done this year, you can always try to solve by graphing. So we either make the two sides, graph both sides. So in this case, if I graph y equals 4 minus x, that would give us a straight line. So that's the blue line in the graph. And then if I graph 16 over x plus 6, that gives us our rational, the red graph. And remember, in that case, we just find our intersection points. So in this case, we graph them. We can see that we get two intersection points. We only want the x value, so we get x of negative 4 and positive 2 is our solution. The other option, remember, is make this equal to 0. So we could go bring the 4 and the x to the other side. So you'd have plus 4, or minus 4 and plus x equal to 0. Graph that, and whatever that graph looks like, we would just look for our x-intercept. So whatever the graph does, we'd have an x-intercept at negative 4, and then we'd end up with another one at plus 2, whatever the graph would do. So graphing will always work, and you can use it. We're going to focus mostly today on solving it algebraically, and then maybe use the graphing just to help us double check to see if we got it right. So with algebra solving, what you got to be careful of is a few of the steps, and you got to be good with factoring and things like that. So first thing what you want to do is make the equation equal to 0. Then you want to factor tops, bottoms, everything as much as you possibly can. And then the trick is multiply the equation by the lowest common denominator. And then you want to solve for x after that. So let's go through an example. We'll actually do the exact same example that we just did by graphing to see if we get the same answers. So first step, take our equation, make it equal to 0. So you can see here I brought the x to the other side, so that made it plus x, brought the 4 to the other side, that gives us negative 4. Okay, now when we look at it, everything's factored, so we don't have to do a factoring step, but we see that we have a denominator of x plus 6. So we actually want to multiply everything in the graph, or everything in the equation by x plus 6. We'd have 0 times x plus 6, the 16 times x plus 6, the x times x plus 6, and the 4. So then we just FOIL it all out. So x plus 6 times 0, 0 times anything is 0. You can see in the second one the x plus 6's would cancel, so we just get 16. And then we'd have x times x plus 6 and negative 4 times x plus 6. So FOIL all those out and simplify it. So we get 16 plus x squared plus 6x when we FOIL those, minus 4x and minus 24 when we FOIL those. And then put our like terms together, we get x squared plus 2x minus 8. Factor that, we get x plus 4, x minus 2, and then from the factors we know our solutions are negative 4 and 2. So we already know those are the answers because we did this one by graphing already, but it's a good idea, or not necessarily a good idea, but you have to do it for these kind of questions, is plug them back in, because sometimes those answers will be an asymptote line or a point to discontinuity or whatever, so we just have to double check. So if we actually do that, let's plug the negative 4 in first. You'd have 4 minus negative 4 on the one side, which would give you 8. And on the other side, we'd have 16 over negative 4 plus 6. So that's 16 over 2, which is also 8. So the negative 4 is good. If we try it with the 2, we'd have 4 minus 2, which is 2. And 16 over 8, which is 2. So that one's good as well. So both answers work, which they should have anyway, because we saw it on the graph that they were both there. So the key thing is with graphing, you will get the right solutions, whether you won't see one that doesn't exist. With algebra, you may get one that doesn't exist. You just have to be a little bit careful. So let's do a couple examples, and that'll be it. So this first one, you can see everything's factored. It's good. So all we want to do is make it equal to 0. So let's make it 1 plus x minus 13 over 6 minus 3 over x. So now in this case our common denominator is going to be 6x, right? Both of the bottoms. So we need to multiply everything by 6x. So 0 times 6x, 1 times 6x, this one times 6x, and the last one times 6x. So 0 times 6x is still 0. That's why we want to make it 0. It'll always make that side equal to 0, which makes it easier. 1 times 6x In this case, the 6's are going to cancel, so we just get x times x minus 13. And for the last one, the x's would cancel, so we get 3 times 6 is minus 18. So let's just simplify this a little bit more. So we have x squared minus 13x minus 18. And let's put all our like terms together. So we get x squared minus 7x minus 18. And now we can factor. So we'd have minus 9 and plus 2. So our solution should be 9 and negative 2. So we could plug these back in to see if they work. And that's one way. Or, like I said, a good way of doing this is to verify graphically. So on your calculator, if you graph these two equations, I'll graph it as two separate equations, and see if it works. So if you graph, I graph the y over 3 over x as the one equation, so that gives us basically a straight kind of flat line, something like that. Then we graph the 1 plus x minus 13 over 6, do that one, that gives us our rational, and it looks something like that. And then we just find our intersection points, so whether you use Desmos or your calculator or whatever, find your intersection points, so we get negative 2 for that one, and positive 9 for that one, which matches our two answers. So even if you're going to solve it algebraically, sometimes it is a good idea to graph it just to double check, and that'll confirm your correct solution. Okay, so let's try another one. Here's a similar equation. So we're going to make it minus 2 equal to 0, or sort of plus 2 when we bring it to the other side. So I'll just do the quick switch here. So now you can see our common denominator ends up being 2x and x plus 1. So the only thing that makes these questions tough is sometimes you get more than just one common denominator. So in this case, we got to do both. So the second one will be, oops, that was 2x, so we'd have 2x and x plus 1 again over x plus 1. And then we got minus or plus 2 times 2x and x plus 1 again. And then the 0 stays a 0, so I won't bother doing that one. So now when we simplify, we can see the 2x's cancel, so we get 3x plus 3. Here the x plus 1's cancel, so we get 2x times 2x would be 4x squared. And our last one we'd have 2 times 2x would be 4x. So 4x times x plus 1 would be 4x squared plus 4x equal to 0. And now if we simplify all this, we get our 4x squareds cancel. So we get 7x plus 3 equal to 0. And we can rearrange and solve that. So x equals negative 3/7. So that's our solution. So once again, we could plug it back in and verify it that way, or let's try graphing it. So let's do the graph first. We got 3 over 2x minus 2x divided by x plus 1. So there's our one graph, and the other one would be just y equals negative 2. So always go back to the original if you're going to graph, and we want to see where it crosses, and according to my calculator here, I'm getting an x of negative 0.429. And so is that correct? Well, on our calculator, if we go 3 divided by 7, we get 0.4285. So these are the same thing, but we can see here algebraically we're actually getting an exact answer, and graphically we're just getting a decimal approximate. So we do know that they are correct, but then you can see the algebra typically gives you a better solution or a more precise solution. Okay, let's do one more. So a similar kind of question. So this one, remember, our first step is make it equal to 0 and factor if possible. So let me rewrite this. We have x over x minus 1. We got minus 2x. Let's bring the other fraction to the other side. So we have minus x plus 1, and let's factor the bottom. So the reason why we want to factor it is you'll see that our common denominator ends up being a lot easier. So in this case, after we factor it, we can see our common denominator is just going to be 2 and x minus 1. Where if we left it as 2x minus 2, we'd have to do way more multiplying and foiling out. So if we times this top one by 2 and x minus 1, this one by 2 and x minus 1, and the last one by 2 and x minus 1. Lots of stuff will cancel. Our x minus 1's cancel, so we just get 2x. And this one we got a little bit more complicated, so we'll end up getting 2x times 2 would be 4x. So we have minus 4x times x minus 1. Here, I'll write it down below. So 2 times negative 2x times x minus 1. And then our last one, everything cancels except for the minus x plus 1. But be careful, that minus goes on both things. So let's put it in brackets so we don't forget. So now when we FOIL it all out, we get 2x minus 4x squared plus 4x minus x minus 1. Let's do all of our like terms. And we got a minus 4x squared. So let's actually bring everything to the other side. Okay, so simplify, bring everything to the other side. So the minus 4x squared will be plus 4x squared on the other side. We get a 4 plus 2 is 6, minus 1 would be 5, bring it to the other side would be minus 5, bring the 1 to the other side, just gives us positive numbers to factor. So a little bit of a harder one to factor. We should have, it'll be 4 and 1, because we wanted to add up to negative 5. So a little bit of a tougher factoring, but I think it works out to be 4x minus 1 and x minus 1. So let's just double check that. If we FOILed it, that'd give us our 4x squared. We'd have minus 4x and minus 1x would give us negative 5, and 1 times 1 is plus 1. So that's good. So those are our two factors. So our solution should be 1/4 and 1. So we want to verify those either by graphing or plugging them back in. So this time let's plug them back in. So if we put the quarter in, that would give us 1/4 divided by negative 3/4. So if we do that, that gives us negative 1/3. Negative 2 times 1/4 would be negative 1/2. And then on the other side we'd get 1 1/4, so 1.25 divided by 1/2 minus 2 would be negative 1.5. So we just want to double check that, make sure it works. So we'd get 0.25 divided by 0.75 negative, so that is our negative 1/3, that's good, minus 0.5, so that gives us negative 0.83 repeating. Do the same thing on the other side, 1.25 divided by 1.5, and that gives us negative 0.83 repeating as well. So the 1/4 is good, for sure. Or we could graph it, and I quickly typed it in, and I can see the graph does cross at 1/4, so that's good. And if we plug in a 1, like if we look at the graph, it's hard to tell if the lines cross, because what this ends up looking like, we get, if you're to graph this, we get a curve, kind of does something like this. So we do get this one crossing at 0.25, but then we see the other one kind of does something like this, and it's hard to see if it's actually crossing or not at 1. The graphs go right side by side as they approach 1, so it's pretty tough to see if they ever cross. So the graph isn't going to help us too much, but if we plug the 1 back into the original, we can see 1 is a non-permissible value. So 1 ends up being our asymptote line, so that means it is extraneous. We won't be able to get a solution with using 1. So in this case, we only get one answer, the 0.25 or the 1/4. And that's all.